Hi everybody. Tonight's video is going to be about linear measure. So we will be measuring line segments. So before we start talking about measure, we should really take some time to define what a line segment is. So in our last video, we talked about lines, but line segments are a little bit different. There's still an infinite collection of points, like a line. So technically, on this line segment, between these two endpoints, there's an infinite number of points filling it in. But a line segment is defined by its two endpoints. So that means it doesn't go on infinitely like a line does. Okay, so instead of a line extending on forever, forgot a parentheses there. So instead of a line extending on forever with the arrows on the end, we are thinking of a line segment as having two endpoints. So in this case, let's call this line segment AB. If this were on a map, again, it would be like a segment that connects two streets but dead ends at each one of those streets, right? So it doesn't go on forever. In this case, I will see this written as, with notation, this line segment would be AB, and it would just have a straight line over the top. It wouldn't have those two arrows that we saw when we were defining a line. So that's how I would see this written. This, again, is not going to have a script lowercase letter like a line would. Line segments are always defined by their two endpoints. And it would be okay to write this as line segment BA. Again, as long as you're using the two endpoints to define it, doesn't matter which order, really. Now, we're going to be talking about the measure of line segment AB or line segment BA. And so sometimes it'll say the measure of AB, and so you won't see the line above the top. So when we're talking about measuring out a line, or measuring out a line segment rather, we're going to be very precise, and we're going to use things like a ruler. So we're going to use our tools that we talked about in the first day of class. So it's going to be very important that when we are measuring this, we're trying our best to be as precise as possible. So let's take this segment here. And if I have my ruler, when I'm measuring my segment, I'm not going to want to put the ruler just like up wherever, right? I want to start it at 0. That's going to be the easiest way to get a good reading on my line segment on the measurement. So if I put my line segment right here, and let's call this line segment BC, okay? And I want to find the measure of BC, line segment BC. So on this side of the ruler, these are inches. So that's 1 inch, 2 inch, 3 inches, so on. And so I can see that this is 2.5 inches. But there's all these other little marks here, right? So this is clear. It's halfway between 2 and 3. So I can say that the measure of BC is or equals 2.5 or 2.5 inches. And I always want to make sure that when I am writing out the measure of something, I'm using the units, right? So it's very important that I'm identifying that this is 2.5 inches. So we see all these other little marks here. And you can look and see, depending on the length of them, that kind of gives you a hint as to what the division is. So here, this is 1/2 of an inch, right? This is halfway between 0 and 1, so that's 1/2 inch. It's not going to let me write on there. So that's 1/2 inch. The other marks, this shorter, it's slightly shorter than the 1/2 inch. That's spaced out in quarters, right? So that's 1/4 of an inch. Then we see this one, it's a little bit shorter, and it would be spaced out every 1/8 of an inch, right? So that's 1/8. And then the very small one is 1/16 of an inch. And those are the common divisions of an inch. So you'll have an inch, 1/2 inch, 1/4 of an inch, 1/8 of an inch, and 1/16 of an inch. And so we could be very precise. So if I wanted to be even more accurate here, it looks like I could extend out line segment BC. Let's select that. Let's move it out a little bit. So now line segment BC actually looks like it's 2, and that's a little bit farther than 1/2. And that would be the 16th, and that would be the 8th. So how many eighths is that? Well, that's 1/8, 2/8, 3/8, 4/8 is 1/2, and 5/8. So now BC is 2 5/8 inches long, right? So I can always just, it depends on what the closest marking on the ruler is, and that's going to be which division of an inch I want to use. So it could be half, quarters, eighths, or sixteenths. Now the other option that we'll see on most of our rulers is the metric system. They use that mostly in Europe, but we can also use it here. That's fine. So in this case, I want to measure using centimeters, which is what this is marked as, 1, 2, 3, 4, 5, 6 centimeters, 6.5, 7 centimeters, and so on. And then the other little marks are all millimeters, and then that would be the longer mark that's right in the middle is obviously half a centimeter. So here, we also have options where we can start saying, we can make approximations in measure. So here I could say this is about 6.5 centimeters, 6.5 centimeters. We'll use the abbreviation cm for centimeters. So you could say it's about that. You might also see just a squiggly line like that is another way, is a symbol for the word about. And then you could also count this off in millimeters. So each centimeter is 10 millimeters. That's why it's nice using the metric system, because it's all base 10. So I know that's 60 millimeters. That would be 65, because it's halfway between 60 and 70 millimeters. And then it looks like that's at about 66, 67. So that would be 67 millimeters would be the more precise measurement, right? So I could say that's about 6.5 centimeters. But if I really wanted to be exact and break it down to millimeters, I'd say it's 67. Okay, so that if we went back to the inches, I could say that line segment BC is about 2.5 inches, but if I really wanted to be specific, it was 2 5/8 of an inch, right? 2 5/8 inches. So that's another way that you can measure it. Now, we have other tools that we use. So you'll see this one sitting off to the side. So we have our ruler that we can use to measure a line segment, but we also have our protractor. So if I want to use our protractor here, our compass, I can use this to measure, and I can use this to draw line segments. So let's put a line segment in here. Let's get that set up. All right, let's do line segment. We'll call this line segment FG. Okay, those are the two endpoints. Now, I could measure this with a ruler, or I can also use my compass. So I'm going to put the edge of the compass on one endpoint. So I'm going to put that on point F, and then I would open it up to point G. Okay, and if I want to measure this now, I can just draw this arc. And what's nice about using this, some of your compasses will have a measurement dial here that'll tell you exactly how many degrees or millimeters or inches that you have the compass open. But what I want to use this for, and why this tool is really nice, is because now that I have this set, I can make congruent segments. So now that I have this set to a certain distance, it's the same distance or length as FG, I can make other line segments that are that same length or measure. So what I do is I make a little arc here. It's in the same spot as FG was, or G was. And then I put the dot down at the bottom, and I put a dot on this arc here. And then I'm going to connect those two points, those two endpoints, with a line segment. And now I have a line segment that is the same length as FG. We'll call this something different. We'll call this MN. So FG and MN are congruent because they are two segments of the same measure. So the way I would write that is I would say line segment FG is congruent to line segment MN, right? So congruent to has its own symbol. That's what this one, it's an equal sign with the little kind of wavy line on top. That's the same thing that we used for about. So this says FG is congruent to MN, which means it's the same measure as line segment MN. Okay? And what we did here using this compass to open it to the measure of FG and then create two other, use two endpoints to create another line segment of the same measure, that's what's called a construction. So we're going to do that a lot in geometry. And a construction is basically recreating different shapes using methods with simple tools like the compass and protractor, or just straight edges and a compass and that sort of thing, where sometimes we wouldn't have a precise measurement, like we might not have numbers. Most of our compasses now are nice and they can tell us some information, but a construction is mostly done with tools that don't have any sort of measurement on. Okay, so that's a little bit about congruence. We'll talk a lot about that more later. And then another thing that's mentioned in the book is something called betweenness. A point is only considered between two other points if it is collinear with them. So if this is line segment AB and I have point C down here, C is not technically between AB because it's not on the same line. It's not collinear. But if I have D, let's put point E here, and F, E is considered to be between D and F because it's on the same line. And the reason that this is nice is because we can use some of this information to tell us different measures of different segments. So if I were to say that 20 is the measure between EF, and the total measure between DF is, let's say, 42, and we can throw in units here if we want. We could say that that's 20 inches and this is 42 inches. Now I can actually figure out the measure of DE because I know that the total length is 42 inches, but the distance between E and F, or the measure between E and F, is 20 inches. So that means that the measure of DE is 42 minus 20, so that would be 22 inches. Right, so that's something we're going to do in class in the next couple of days. We'll also do some algebra with that. So again, the idea is just to make sure that these two parts that are split up by a point in between add up to be the total, and we'll do some examples like that in class. Have a great night and bring these notes with you tomorrow.